Okay, good morning. Welcome to Fun Math number 142. Today we're going to study something really cool that I saw in London. A 3.5 gon.
Nobody expects a 3.5 gon.
A 3.5 gon? What is that? Okay, well, we know what a 3 gon is. What's that normally called?
A triangle.
And when all the sides are equal, what's that called?
An equilateral triangle.
And you know what the angles in an equilateral triangle are?
60.
60, that's right. 60 degrees. All of them are 60. Why is that, by the way?
Because angles in a triangle sum up to 180.
Yeah, angles in a triangle sum up to 180. What about this, a quadrilateral where all the sides are the same and all the angles are the same? What's that called?
A square.
A square. And what are the angles?
The angles are 90 apiece.
90 apiece. Why is that?
Because angles in a square sum up to 360.
Okay, very good. And what is it called when you have 5 sides, all sides are the same and all angles are the same?
The pentagon.
Pentagon. It's a regular pentagon, even if I can't draw it right. Do you know what the angles of a pentagon are, by the way?
No.
You remember the formula for how you figure it out?
Well, it's n minus 2 times 180.
N minus 2 times 180 over n gives you each angle, right? So we have 3 times 180 over 5. And what's 180 divided by 5? Ooh, interesting. Can you do 180 over 5 real quick?
180 over 10 is 18.
Yeah?
It's 36.
So it's 3 times 36, which is?
It's 90, it's 108.
108. Very good. So 108 in a pentagon. But I saw on Twitter, actually, this, sorry, not paying attention, it's still in London time, 108. I saw on Twitter somebody asked the question, a guy named Dan Meyer, who does some really cool math. He said, well, what if we have this formula here, n minus 2 times 180 over n to get each angle, but we don't pick an integer? So he said, well, he gave an example of 3.5, which was pretty cool. So 3.5 minus 2 is what?
It's 1.5.
1.5, and we're going to do times 180 over 3.5. So let's simplify this first. 1.5 as a fraction is?
It's 3 halves.
3 halves. What's 3.5 as a fraction?
Well, it's 7 halves.
7 halves. So what's 3 halves divided by 7 halves?
3 halves times 3 sevenths,
Or?
which is 3 sevenths.
3 sevenths. Very good. Times 180, and we won't do that. This is about 77. So he said, I'm just going to make 77-degree angles, and you can probably see the dots on the screen because I had to do this ahead of time just so I wouldn't draw it all goofy. But he said, I'm just going to start at a point, I'm going to go off, and I'm going to make these 77-degree angles. And you get a 3.5 gon. That's kind of weird. Do you notice anything interesting about our 3.5 gon?
It's overlapping.
It does. Things overlap, yeah. Do you notice anything else interesting?
Well, it's made up of triangles and some odd shape in the middle.
Yeah, it is kind of an odd shape in the middle. How many points are there?
1, 2, 3, 4, 5, 6, 7 points.
That's right, 7 points. How does 3.5 relate to 7?
3.5 times 2 is 7.
Ah, interesting. I wonder if we can. I wonder how this is going to work out. I mean, what if we picked, instead of 3.5, which was 7 halves, what if we picked something that was like 5 thirds?
What if we put a pi-gon?
What if we picked pi? Very good question. What if we picked pi?
Pi-gon!
This is pretty neat. This is a 3.5 gon, sort of. Pretty neat, right?
Yeah.
All right. Good job. Good job. Fun thing to learn about.